Good morning, everyone. Welcome to our Wednesday edition of CPT 168. And it is a beautiful Wednesday morning here in downtown Taylor, South Carolina. Well, actually, I'm not downtown. I'm kind of in the burbs of Taylor's, if you can believe that. I hope you guys have been having a good week. It's been a pretty good week over here. A lot going on, trying to get out of this COVID thing. And want to get into our lesson fairly quickly because we have a lot to do today. It's a big unit to go over, but it's important that we talk about our test first. I did not look at it before class. I guess I should have, but let's see here. I got to get a couple things straightened out here on the screen. And so you guys have test number 2 underway right now, and it is going through 11:59 tonight. So be sure and get test number 2 submitted today if you haven't done so already. Yesterday I looked at it and I went through all 4 sections, and I was somewhat encouraged. It was looked like the grades were pretty good. I think the lowest grade was a 78 and the highest grade was in the 90s somewhere. So it looked like it was going to be a good test, but the early test takers, the guys that take them on Mondays, normally do pretty good. And it's the ones that take it 11 o'clock on Wednesday night that I worry about. So anyway, get your test in today if you haven't done so already. We have a big chapter, as I said, in our textbook. It's an important skill set for us because we're going to be using it the rest of the way. I know I say that every week, but it's true. We're building on our previous skills. And so in Unit 7, we're going to learn how to work with file, input, and output. Basically, how to read and write and adjust and change data stored on our SSD or our hard drive, whatever kind of storage system we have on our computer. This is very common in computing. You do it all the time in the programs that you use. And so it's important for us to learn how to do this. We're going to learn how to use text files as database files too, which is interesting. I think that you can get a lot of programming done without using SQL. SQL certainly makes things nicer and faster and more stable. Don't have a problem with SQL. But before there was SQL, there were flat file databases that are either text files or binary files that we saved on our hard drives back in the day. And so we're going to learn how to do that today. And that is the main point. So that's kind of interesting. So study chapter 7. Also take a look at the topic for the forum and do a good job with that. Most of you guys are doing a good job with the forum. I'm going to get a little stricter on the replies because some of you guys have slacked off out of the 68 students taking this class. Some of the students are not doing all 3 replies each week. And so a reply is going to cost you 10 points the rest of the way. And I think I sent you an email, probably on Monday, a little feedback on that. And so the whole point of the discussion forums is to discuss. And so you have to do that by reading what your classmates post and replying. If I didn't require it, you probably would do it all over the place. But now that I require it, it seems like it's hard to get people to talk to each other. But hopefully it'll work. Most of you guys are doing it okay, I guess. Well over half the class is doing it okay. 3 labs this week. A lot of practice with our text and binary data files. We'll talk about that as we go through the class today. And also you have your quiz for this week. So get the test done today. And then you got the rest of the week to do the discussion post, 3 labs, and your quiz, okay? Next week, we're going to get into exception handling. And we actually kind of preview that just a skosh this week because we're going to see that it's real easy to have exceptions when you're doing file I/O. So next week, we will add a solution for that when we get into exception handling. So see how things kind of build on each other from week to week. And after next week, we will be through section 1 of our book. And if you remember back when we started back in January, I said once you get through the first section of this book, you have learned enough Python to really write programs that actually do stuff. And from there on, for the rest of the course, we're just going to add higher level skills on top of the base that we learned, the basic parts of how to handle Python in the first 8 chapters of the book. Also, when we get through with this week, this being week number 7, we will be 1/2 way through the semester. This is a 14-week semester. This is week number 7. We have to complete it before we celebrate our halfway point. So that's why we're doing test number 2 this week, because that's half of the tests that we have in the course. So I think all this makes sense. Does anybody have any questions about what lies ahead for us in the next week or so? Well, if you do, let me know. If you don't, we'll just move on and get into file IO. I don't see any questions. Don't hear anybody. So Unit 7 is on how to work with file input and output. We're going to learn that all of our files that we are going to use for data collection, for data storage, are either going to be text files or binary files. Now, within each of those 2 types of files, there are going to be different formats of files. And those formats may be TXT files, HTML files, JSON files, XML files, image files, executable files, on and on and on. So all different types of files and formats of files, but they're going to fall within text or binary. And we're going to learn how to read and write to those types of files today. We're going to learn that our friend for this chapter and moving forward with file handling is going to be the with statement, because there's a real neat super feature with the with statement. It helps us open up a file and keep it open while we are reading and writing to it, and then it automatically closes the file when you come out of the with loop. That is huge. It saves having to use an additional method to close a file every time you open one. So I don't see why anybody would not use the with statement. The with statement is hugely important for us in the handling of file IO. We're also going to talk about the CSV module. One of the most popular types of text files for developers, especially with smaller projects, are CSV files, comma separated value files. And basically each field in a record is separated by a comma. Each row in the file is a record. So all of a sudden, because we have rows and we have commas separating fields, we have a spreadsheet. Basically, it is columns and rows in a text file. And so we're going to learn how to use the CSV module, which will allow us to create writer objects and reader objects, because this is all about object-oriented programming. And once we are dealing with the CSV module about halfway through this unit, we're dealing with the list of lists as we store them on the hard drive or SSD in our server or our computer. So that's exciting. And then the last part is kind of anticlimactic, because we spend about 80% of the chapter talking about text files. And then we say, oh, by the way, if you use the pickle module, and I'm not making that up, the pickle module, you'll have a couple of methods, the load and dump methods. And if you just use those instead of the methods we learned for, say, CSV or whatever we're doing for text files, if we just substitute the pickle module for that, then we can deal with binary files. And so that is the end of our chapter. So at this point in CPT 168, you have been working with data that has just been stored in memory. It has not been saved from session to session. I'm sure that you have thought about that, you keep creating these lists and lists of lists every time you write a program. And that's really not the way it works. You've done enough use of computer programs by now to realize that you have to have persistent data that is carried from session to session of the user. And so that is what we're going to learn today, how to do that, how to save data in a file, then how to read it, and how to change that data if we want to. And all that is just basically called file input and output. As I said, there are dozens of types of files. I would like to say that those are dozens of file formats, okay, because really these fall within two general types, text and binary. So text files store its data as characters. Each line ends with a new line character. That's important to remember. We have to deal with that issue. So each line in a text file automatically has a new line character. And then there are binary files which are similar in a lot of ways to text files, but they store data as one giant long line. Okay, it's not in separate lines. That's one thing. But the big reason we like binary files is we can store numeric values or numeric data types in binary files, integers and floats, whereas in text files, we have to convert all of our numbers to strings so they can be saved. Text is only strings, just strings. And we'll be aware of that in spades here in a little bit as we go through this. So by definition, a text file contains one or more lines that contain text characters. In the text file, each line ends with a new line character. On Windows, just to be different, this character is sometimes, I would say almost always, preceded by a carriage return character. So we have a \R and a \N. Common types of text files are CSV files, which we're going to learn today, JSON files, XML files, HTML files. I know you've worked with those in other classes, and we will, if we did this whole book, we would do them in the second half of this book. We're not going to get that far in this one course, but those file types are also dealt with, file formats. Binary then is any file that is not a text file. That's a good way to look at it. If it's not a text file, it has to be a binary file. That's just the process of elimination. Many binary file formats contain parts that can be interpreted as text. As a matter of fact, if you open up a binary file in a text editor, you will see it's one line and just goes forever. And then you'll see text, and then you'll see gobbledygook, and then you'll see text, and then you'll see a bunch of characters that don't mean anything. So some of it can be interpreted as text. However, binary files typically contain a sequence of bytes that are intended to be interpreted as something other than text characters, i.e. integers and floats, okay? So common types of compile files are image files, audio files, that's one I forgot, video files, I forgot that one too, database files, and we're talking about SQL files, for example, and compressed files, anything that's been zipped. So two different big groups, types of files we're going to be dealing with. So comma separated value files are very common. They're very handy to use. One thing that is important to remember about CSV files, you can open them in Excel. They'll open in Excel, and you can use an Excel or a tool like Excel. I know there's some open source alternatives to that will open a CSV file and allow you to maneuver the file in a GUI. We're not going to do that. We're all about doing this with Python in this class. So I just think that makes CSV files, that's one of the reasons why CSV files are so popular. Another thing is you can import CSV files into SQL very easily. There are tools for that. In the PHP world, I talk about PHP a lot in class, there's a tool that I install on all of my servers, my PHP admin, which allows the easy import of CSV files to create table or tables of for a database in SQL. So from our textbook, we have a screenshot of Microsoft Notepad here, opening up a movies.csv file, just a little text file. Now, I don't want to, I'm going to do a little sidebar here, break away from the book for a second, which I think that's what they pay me to do. Don't use Microsoft Notepad when you are working on Python data files, okay? I just don't think this is a good idea. They put it in the book so it'd be something that everybody would recognize, okay? But the fact of the matter is, when you start introducing a Microsoft editor to your data files for Python, you're just adding an additional control character at the end of each line, that return character. And so my suggestion is to use Notepad++, which is a free download. If you haven't already done this, just Google it, Notepad and then 2 plus signs. You could even write it out, Notepad plus PLUS if you wanted to, and you would find it. It's a free download, and set up Notepad++ for Unix format. And then you won't have that extra return on the end of each of your lines. It sounds like a small point, but when you start dealing with it every day, it's a pain. And I have fought that battle too many times. So we've got 3 Monty Python movies in this database. Almost everything in this book, all the data we use just about when it comes to movies anyway, is based on Monty Python. So because that's where the name of our language came from. So Monty Python and the Holy Grail came out in 1975. Cat on a Hot Tin Roof, 1958. Maybe that one's not a Monty Python movie. I thought I had this squared away in my brain. On the Waterfront's not a Monty Python movie either. So scratch that. Only one of these is a Monty Python movie. There are examples of other data files where we have all Monty Python movies. So if we open up that same file after saving it as a binary file, you can see that there's a bunch of gibberish in the file. And this is what we were talking about before. So these are either control characters or numbers or float values somewhere in here. This is probably the year that we saw in the previous screenshot. But you can see we still see some text. So you'll see a little bit of both. And also notice it's just one long line. It's not broken into lines for us with end of lines. So that's the difference between text and binary, and one's not necessarily better than the other. Having dealt with this for decades, I will tell you that text files can get corrupted. Back in the old days, they got it corrupted, especially if you open up your programs to the public and you have people that are entering data that's not valid. That's why data validation is so important. And once you get your database corrupted, it can be a problem. And more times than I care to remember, I actually have a good example of that. If you go to radiolinks.net, it's a program I put on, or a web app, I guess I should call it. I put on the internet 10, 15 years ago. It's a Perl script that, and it's run in flat file databases. And back in the day, before Apache has gotten as good as it is now, I would at least once a month have to go in there and fix the data files. Something would get screwed up. I've not had that problem with SQL, not so much. Okay, so, but text files can get corrupted. Any file can get corrupted, but when you're doing I/O on a file constantly, that's when it can get messed up if you're not careful. So back to the program here. There are 3 things that have to happen in order for you to do file I/O. A sequence of operations here. First, you have to open the file. Now we're going to use a function to open the file in Python. And that function is going to have two arguments. One is going to be the name of the file that we want to open, and it can be the absolute path to the file, or it can just be the name of the file, and it will look in the current working directory. We'll get to that in just a second. And then the second argument is the mode that that file is going to be opened in: read, write, or append. Okay, or binary. Yeah, that's also part of a mode. So we have to open the file. The second thing we have to do is read the data from the file or write data to the file. Pretty simple, read or write. And then the third thing is we got to close the file. We do not want to leave files open. That is for sure how you can corrupt files. If you leave files open after you finish working on them, something is going to go wrong sooner or later. Plus, you're wasting computer resources, which is not a good thing. So what we're talking about is using persistent data storage. We want to write data to a file, and then we want to read the data from the file into memory. So very simply, we start an application, we open a file. Sometimes they open automatically. Sometimes the user has to ask them to open, and there's going to be a read. That file will be read into RAM. Then we can process the data in that file, do whatever we want to, and then we can write the data. Now, one thing we're going to learn, and I'm kind of pre-selling here, but one of the things we're going to learn when we write data to a file, when we write, do a typical write, it is going to rewrite the whole file. So essentially, you have to read the whole file into memory, process a bit of the file or the whole file, whatever you process, but we have to write the whole file back to the storage when we're done. The only way we can get around that is by using an append, which we're going to get to here in just a second. So just about every time you deal with a persistent data file, you're going to read it, you're going to process it, then you're going to write it. Okay. So there is one major gotcha that is going to be dealt with in our next chapter next week. And that is if you try to open a file that does not exist. If you call for a file that does not exist, your program will crash. It'll basically give you an exception that says that file does not exist. I cannot go any further. Have a nice day. So we need to, in our next unit, learn how to write code that deals with that issue without crashing our program. That's the thing. We need to be nice to our users and not crash on them. Now, if we happen to write to or append to a file that does not exist, it will be created for us. That's a nice thing. We don't get an exception that way. So a little bit about extensions on files. We're going to be all about TXT and CSV pretty much in this class, a little bit of BIN, but TXT for text files or CSV for comma separated value files or just comma delimited files. Binary files that contain data as opposed to a binary file that is an image or an audio file or a video file or an executable file. Those would have different extensions, as you know, but a binary data file typically is going to be a .bin or a .dat. And it's pretty easy to understand what those extensions mean. .bin would be binary or .dat would be data, okay? And I do know of situations where .bin is used for an executable file, which bothers me just a skosh when we're talking about best practices here and things that we should do. I kind of like .bat for, .dat, not BAT, but DAT for binary data files. That makes common sense to me, but certainly .bin for binary works, okay? So our friend throughout this whole process is going to be the open function. Step one of those three things we have to do for file IO is to open. And this is the easiest part to be, well, I guess the easiest part is closing because we're going to let the while statement do it for us. but pretty easy is going to be the open function. And it's very consistent throughout this whole process. You will see while statements running the open function to start the file and open the file and create a file object in memory. So that's the whole point. We want to open the file, we'll create a file object in memory, and then we can do stuff with it, okay? So it accepts both a file and a mode argument. Typically, these are not named arguments. You could name them, I guess, but the first one's always the file and the second one is always the mode. Later on, we're going to see a third argument that is a named argument, which we'll get to. So it is nice that the first argument, the file argument, can be a complete path to the file. And you would think maybe that would be very absolute, be a very responsible thing to do. Actually, that's not such a good idea. Okay. We should try to, especially in this class, we should try to keep our data files in the same directory as our program files. And then we don't have to worry about anything but the name of the file and that file argument. And that's normal. That is very normal for programs that we're learning how to write. That makes it very portable. Say, for example, I wrote a program for you. You sent me a big fat check to be your developer. I wrote a program for you. I created a data file or two, and I put them all in the same directory and maybe send you a zip file to unzip on your computer, and they will work. And we're going to learn how to write these files so they will work on your Linux computer after I created them on my Windows computer. And that's a trick. So we need to be able to make these files portable across operating systems to really do a good job. So, and we talk about this in other programming classes too. We need to think about portability and ease of operation and ease of administration. So for programs like this, just keep the data in the same directory. Oh, you see the syntax down here at the bottom. The open function, open, and then inside the parentheses, the first argument is the name of the file, a comma, and then the mode, okay? So let's move into this mode thing a little bit. Typically, you're going to open the file in either read or write mode. You may open it in binary mode as well. So read mode is the default of the open function. Now that is an important statement. Read mode is the default mode of the open function, because right away in this book, our authors' examples, our writers' examples will not show the read mode. And so if the mode argument's not there, you have to realize it is read mode, okay? You can also use append mode, which will add a line to the end of an existing file. That is used a lot, okay? Because that will save us a lot of time as we process our data, okay? And then we can include binary mode along with read or write mode. That's at the end of the chapter. So I have a table that that kind of breaks this down for us. And it's all about not crashing our program here. So the character R for read is, if you want to show read mode, that would be what you would want to include for the second argument in the open function. And if the file does not exist, then you crash your program. Now, W for write and A for append will do exactly what you think they will do. Remember, if the file does not exist, the data file does not exist, it will be created. It will not crash. That's the good thing. Also remember, when you write to a file, if the file already exists, the mode erases all existing data. So however you're feeding data to that write command, you've got to account for all the data that you want saved. Whereas the append mode will add a line to the end, which is a little bit easier to deal with. Binary, you're going to see it at the end. It's going to be BR or BW for binary, and you have to include BR. It's not a default. So if you want to use binary for reading, it has to be BR. So I think I've already established this for you a couple of times. The big difference between read, write, and append is what happens if the file does not exist. Just realize it is the innocent looking read mode that can crash your program if you fat finger the name of your file. Have to be careful because I get to grade your labs and I see what lousy typists you are at times. And so if you fat finger that the name of that file, you could crash your program. So be careful about that. And I think you're going to get a nice exception on the screen that will point you in the direction. Idle will tell you what line the problem's in and where to go fix it. So for every file that you open, you have to close. Once you have processed the data, you have to close. And this is something that you should do immediately after you process the data. You should not, and some people may think logically that, well, I'll just open all my files at the beginning of a program, do all kinds of stuff to them, and then at the very end, I'll close them. And that would be a rookie's mistake. You would more than likely end up corrupting something somewhere. So just realize you got to go one data file at a time. You got to open it, process it, close it, open it, process it, close it. There's a lot of file I/O going on when a program runs. Now we do have a close method, okay? The problem is people forget to use the close method. And the close method is very simple. You just close a file object in the objects in the parentheses. So by way of example, and this is super simple. It's not really practical, okay, but it's super simple. So we're using the open function here to create this out file object, okay? So open, here's the file that's on our hard drive, and it already exists, which is not shown in this example, but it already exists, or we would get an exception. It's named test.txt in the current working directory because there's no path here in this name, and we want to open it in write mode. Then we can bring up the write method. Here's the object. It's object-oriented programming. The object now, we created the object in the first line. The second line, we are using a method on that object to write test to that file. Now, as soon as we run that write method, test.txt is deleted. It's basically overwritten, and the word test is put on there, and there will be an end of line character at the end of the word test in this example. And then to close the object, we have a method here, close, and then we don't even have to put the file name in the parentheses. And this is the only place you're ever going to see this. I don't think you're ever going to see our examples in this book and what we're learning in this course use the close method again. But that is how it works. I think I might have called it a function here. I just want to look at my notes to make sure I had it right. It is a method. It's not a function because we are working on an object. Okay, so the good news is we can just forget about that close method. We can use a with statement to create a loop that will open a file, keep it open while we're processing data, and then when we come out of that with statement, when we exit out of that loop, then we will close the file. Now, one thing I failed to say right here, which is actually in my notes, with the close method, this is the second reason why we don't want this. If there's ever an exception between opening and closing the file, the close will never happen. It has to be pristine, perfect code for the close method to work. Whereas if you use the with statement, then if there is an exception before the with statement closes or exits, then it will still save the file. It will still close the file. Okay. And that's a good thing. That makes it possible for us to be a tiny bit sloppy. We still got to check our work and make sure things are behaving themselves. But the fact of the matter is, we can have an exception and still move forward. Okay, so that's a good thing. So we'll take a look at an example here. We'll see how we'll open the file, we'll run a block of statements, and then we will come out of the with loop and everything will close nice and neat. So the syntax for this to work, we start off a with statement with the with keyword there. Then we run the open function and then the as keyword to create the file object and then colon to end that line. So this is just like the with loop that we've seen before, but we are using the open function here to control this file IO. So with open file name mode as this file object, then we have a bunch of statements. This is the processing of the data, whatever we're going to do to it. And then when we come out of this with loop, automatically the file is going to be closed. So this is a simple example of what we just saw with 3 lines of code. We're going to do it with 2 lines of code now because we don't have to close. So with then our open function test.txt in write mode as out file, there's our file object and the colon, okay? Then we can run the write function on it. Out file is the object, write is the method. Did I say function again? This is a method, write method, and then our argument there is going to be test. Okay, same thing I just said before. It's going to be the word test, and then a new line character at the end. And we don't have to do anything. We go into the next line in our program. The with statement will close the file, and life is good. And going in the other direction to read a file, it basically looks the same. We have an R instead of a W here. Fact of the matter is we don't even have to have an R there for a second argument, which you'll see that go away in the next example, I think. And then as in file is our file object here, and we're just going to print it. Okay. So print in file is our object dot read line. Now this is a method we're going to read about or learn about here in just a minute. We're going to read one line. It basically reads the next line in the data file that is open. And so if we're at the top of the file, the next line is the first line, right? So it would read the first line, and it's just the method, so we have to have parentheses on it. But pretty simple. It's nothing hard about this. So when you open a file object in write or append, and you use the write method to write or append the data to the text file, each line is going to have that end of line character or new line character at the end. Okay. So really all you have to do is pass one argument, which is a string, okay, for that file. With either mode, you pass one string as an argument. That's going to be the name of the file. There we go. Get it right. It's going to be the name of the file. You can convert other data types, okay, while you are processing the data in there. And that can be, okay, I'm screwing up big time here. So the write method, let me get back up here. Inside the parentheses here in the write method. All right, I was right the first time. I changed my mind and I should have stayed with my original thought. Because inside these parens, you are going to put the data that you want to save on that file, the whole file, okay? And it's going to be a string. Everything has to be a string. That can be a bunch of lines, which will have the new line character at the end of each line, but it's going to be a string, okay? That's the point. So if you have any integers or floats, they have to be converted to strings before you can write them to the file. That is the point, okay? That is the point. Maybe if I screw up more, you'll remember what I'm saying. I don't know, but that's what we're trying to do with the write method. So write, and then whatever that string is. And we're talking about a big string. It could be a big string if it has to be. Typically, you're going to have a bunch of writes that are going to pile on. We'll see how that works here in a minute. So one line to a text file, very simple. So with open, we're opening the file. Okay, this whole thing opens up the file, and then file, which is the file object, dot write method. Okay, and here's our string. Notice one very important thing here. When we are entering a string as the argument here, we want to enclose it in double quotes. Always. That makes this very readable for your code review, and it also makes it work smoothly. The append, okay, is an A instead of a W for write. It's an A. And so this will not overwrite the whole file. It will just add to the end of it, okay? So file.write, we're just going to append. So it's an append mode, but we use the write method, and we add Eric Idle, the person that the Idle IDE was named for, as the second line in this file. These guys were in Monty Python, okay? John Cleese and Eric Idle. So we were to just look at this file now in a text editor. We would see two lines. We could see if we uncovered the new line characters, you would see them. So that's how they were written, and the text editor should process those new line characters, so we see it as two separate lines of text. All right, so let's go on to these other methods that we can use when we open up a file. And this is very important because we have to be able to process multiple lines of code in our text file. And so there are different ways that we can do this. We have three different methods. They do three different things, and they look very similar. So that to me is a bit of a problem. We're going to run these methods inside a for statement to loop through the file typically. Okay, not always, but typically that's what we would do. So the read method, okay, reads the entire file. It returns the contents of the file as a string. So if you want to read the whole thing into memory as one big block, you could, okay? Read lines, and this is important because it has an S on the end. This is plural because there's also a read line, which we saw a minute ago. So read lines reads the entire file into memory, but it returns it as a list, which is important. That makes it maybe a little bit easier for us to process if it's a list. And then the third one, which is very common, is read line, okay? It reads the next line in the file and returns its contents as a string. So that allows you to process each line one line at a time. So to really make this happen, we want to run through a for loop to get, and we're going to see an example here. We're going to get each line and we're going to print it. And we're going to do it different ways to show you how those methods behave, okay? Now, remember that because we are dealing with strings here, we've tried to make it very apparent that each line has a new line character at the end. Unless it's Microsoft and we already blasted them for their return character. So right now we're just going to deal with a new line character at the end of each line, okay? Remember that the print method also puts a end of line character or new line character at the end of each line. So now we got two of them, okay? So that is a bit of a problem. We have to change the end of line argument, which is part of the print method, to an empty string so we don't get a blank line after each line. That's, you've probably seen this even in production software. I've seen it before where there's everything is double spaced and you don't want it double spaced. Well, this may be what the problem is. So we're going to see right off the get-go here, right at the beginning, how we're going to change that end of line to a null with the print method, so we don't have those blank lines. So in this example, we're going to look at the code does not call any of the read methods in the previous table, because the for loop automatically calls a read line method to get the next line in the file. Think about that a second, the next to last bullet here. So by default, the for loop uses the read line method. By default, the open function uses the read mode. So now we got two things that are going to happen in our example that we're not going to see. Okay. So I don't know if I agree totally with the writer of this chapter dumping these kind of shortcuts on us, but they're there and we should be used to them. Okay. So just understand that they're there, and when the code looks like it's wrong, it really is right, as I will try to show you here. So there are 4 examples here that do the same thing. We want to kind of see how we can do this in different ways. So first off, we need to open the file. So with the open function, we're going to open members.txt. Notice there is no read mode here because that's the default. As file, we're creating this file object in memory. We have a colon on the end. Now we can have a for loop that's going to use the read line method. So for line in file. So now file is going to be read one line at a time as we loop through, and it's going to print it on the screen on the console. So it's going to print a line, and it's going to change that end of line character to nothing. That's because each line already has a new line character, and then we'll print a blank line once we get through. So that's a nice, neat way to do this. This is very easy. Here's another way to do it. Okay, we could do just the whole thing at one time, the entire file. So we'll open the file. This is all the same here. Notice read mode is the default. We're creating the file object. And so now we're going to create a new object here called contents. And we're going to use the read method on the file object to get those contents, and then we can print contents. Okay, that is real easy too. Now we could do this as a list. Okay, we could do a read of the entire file as a list using the read lines with an S method that we saw. So once again, we're going to open the file. We've opened the file 3 times, exactly the same way. Starts changing on the second line. So we're going to create the members object, which is going to be based on the file object with the read lines method. Okay, so that is going to open the entire file as a list. It's basically a list of lists if you really want to get into it, but right now we'll just call it a list because there's only 2 things in it. So we can print now. So we can print the first line, which is 0, then the second line, which is 1. Those are the 2 names. That's all we have. We don't have a whole lot of data in here yet. So it's just a list right now. It could be a list of lists. Notice that we use the end named argument here to change the end to a nothing to get rid of that new line character that is the default of the print function. Last example, how to read each line in the file. And this is actually more common than you would think, okay? Because we're going to create a different object for each line of the file. So with open, we're going to open up this is all exactly what we've already said, so I don't have to say it a 4th time. But look at the code after that. We're going to create the member1 object here, which is going to be the result of looking at the file object and using read line, which is the next line. It's going to be member1, and we can print it. Use the named argument here to change the end character. Then member2, look at the second line. We could actually do that for each line. This is not real efficient. There's no for loop here, okay? So the for loop actually makes this a little bit neater, I think, okay? But it's at the end of the day, with this little example that we had, all 4 of those examples get the same result. Can you use, Joshua was asking, can you use the print function with the read method inside of it? That's a good question. And my immediate thought is it's not covered in this chapter, so I would have to test that to see if it works. I've never done it that way in my work, okay? But it might work. You just have to test it and see. Inquisitive minds want to know. Sorry, I can't help you more than that. I'm thinking it's not going to work. I'm thinking it's not going to work. Let me know if you test it before I do, and tell me whether it works or not. All right, so let's look at how to deal with a list. I kind of got ahead of myself a minute ago. I did that yesterday too. But lists are so important to us. So we're going to look at a list and then a list of lists as it applies to these text files that we're dealing with. So our next example is going to show us how to write a list to a text file and how to read the list from a text file. And once again, I think you're going to see a for loop really makes this easy, because a for loop is going to do a read line by a read line method. It's going to use the read line method by default. And so we can just be busy about our write method or append or whatever we're going to do, okay? And we're also going to add a new line character here to the end of each line in the string, okay? You'll see that in the code. So here we are back to our old ways from last week, where we are creating a list, and it's just a simple list named members here, okay? It has two names in it. And then we are going to write this data. This is a way to create a text file, a text data file. So the with statement, we're going to open up the text file, and we're going to do it in write mode as a file object here, and run it through a for loop. So for m in members, okay, members is up here. That's the whole list. So M is our variable that we're creating for each of the lines in the members file. And then we are going to, because the for loop automatically uses the read line method, we're going to get one line at a time. So file's going to write M plus we're going to add to it, concatenate to the end, the new line character. Okay, so that's basically building the text file to its default status, where each line will have a new line character. If we didn't do this, because these two members are coming out of this file, they do not have new line characters, but we want the output to be each of these guys on a separate line. So we have to add that new line character to get that to work. We would figure that out once we looked at our output and it was all together. You say, oh, better put a new line character on there. Now, we could also use something called the replace method to deal with that new line character as well, okay? So to read that file, to read it into memory, we'll run a for loop again to bring in each line of the file. We're going to use the replace method to replace the new line character with an empty string to get rid of the new line character. The code then is going to append the string to the members list, and then we're going to print. You'll see we'll run to a print function. So remember, the list is on the file where members.txt is already created. So for memory, we need to create an empty list here so we can populate that. Remember back to last week, we're going to use code that we learned last week. So with open, we're going to open up the data file that's on the persistent storage somewhere as this file object. Then we're going to run it through a for loop. So for line in that file object, each line, we're going to run it through a replace method to get rid of the end of line that we just added, but now we don't want it because we're going to create a list. we want to replace that with nothingness. So that's going to remove that new line character. And then we saw this code last week for members in our brand new list up here. We're going to append that line. So we only have 2 names in this file, but if it was 200 names, this would work. Okay. And then we print members. And notice when we print members, it's going to be a list. It's not going to be each one on a separate line, but it's going to be a list with 2 indexes in it. All right, so now we're going to deal with data type a little bit. Next set of examples shows us how to work with integer data. And we've got to convert that integer data to a string. In this case, it's going to be a year for those movies. And when we read the data, we got to convert it back to an integer. And when we write the data, we're going to have to convert it to a string. Okay. We're going to use the replace method to do this, which is going to make this easier to understand, I think. So first off, we're going to do a write. We're going to create the file. We're going to take this pre-built data that we have and create a file. So remember, the write mode will create a file if it does not exist. It's not going to throw an error for us. So here's our years. These are all integers. And we're going to open the file years.txt in write mode. Well, that does not exist, so it's going to create it for us. And we're going to create this one as years underscore file. So years file is going to be the object we're going to work with. So for each year in our list of years, we saw this last week. So this is a loop through that list. Years file, we're going to write, and notice we're embedding the string function here to change each of those integers to a string and add a new line character to the end of each of those years. So that's how you do it with integers. To read them, go in the other direction. To take them out of the data file and put them into a list in memory, we have to open up in memory an empty list, then run the with statement, which we have seen many times here. Remember, there's no mode here because read is the default, okay? File is our object. So for each line in the file, it's a simple for loop here, then we're going to replace the end, which we saw in the previous example. So each line, we're going to run the replace method to replace the new lines character with nothing, a null. And then we're going to append. And this is using the code for the list. So in the years list, we're going to append the integer line. We're converting it back to an integer to put it back in our list. When we run this print function here, we see we have a list. Okay. Nobody's asking any questions. This is a good place to do it before we see this in a little program. Either you're totally asleep or you're getting it. Hope it's the latter, you're getting it. Okay, so we're going to continue messing around with this concept of a movie list. This one's very simple. It's a lot like what we were doing last week, but we are going to store the data on a hard drive. Okay, store our data in storage. I keep calling it a hard drive. Can't do that anymore. We all have SSDs. So on our storage system. So I don't need to explain the interface to you because you saw it last week. So let's look at the code, and you're going to see that much of this code is just like what we saw last week, except for the parts that deal with reading and writing the data off the storage system. Let's say a few tricks here. The first line is a trick. So our file name is movies.txt. It's located in the current working directory. So we're going to create a variable to make this easy to deal with called file name. We're going to capitalize it because we want it to stand out in our code here for emphasis. So we're going to define this function, write movies. So we have to open the file name. We have to have it in write mode, create the file object. And then we're going to loop through the movies database and write that file. So for each movie in the movies list, we want to run the write method on that file object, movie plus the end of line character. We're just basically doing what we just saw, okay? To read the movies, we create another function. Just like we just saw, we create a empty list, and then we use a with statement to open up our file. We don't have to include the mode here because this read is default, okay? Create the file object and go through each line. So for line in file, there's our for loop. We're going to read it one line at a time because that is the default. Read line method is the default. So line's going to be run through the replace method here to take the new line character off, and then we're going to append the movies list with each line that's in that file. And now we have our list in memory so we can start processing it. That being said, this function, I don't mean method at all there. This function is the same that we saw last week, so I don't need to explain it. We already did that. The add the movie is the same as last week, okay? Because we are dealing with the list. We're dealing with what's in RAM, not on our hard drive. And this is deleting movies. We're dealing with what's in RAM. And then our display is the same as it was last week. And then our main function, because our data's in RAM, same as last week. So there you go. Now, big difference is write movies function and read movies function. So when we run the write movies function, we should take everything that's in our list and save it on the hard drive, remember? So that would be our write. And here's where we run the read movies function that we created. And we go through and process all this stuff. Okay. Moving on to CSV files. Now we can take one step further to being, and we're going to come back to the movies list with using CSV files, so don't panic. We'll get back to some more of that code. So when you use a plain text file to store data, you need to separate all of the different fields with a comma, okay, to create a CSV file. For us to process that, we're going to have to use the CSV module. But just realize in a CSV file, each line is considered a record, and all the data between those commas, each one of those commas separates those data into fields or columns. So if you can think of a CSV file as the table in Excel, you would be point on, you would be right there. As a matter of fact, once again, if you were to open a .csv file with Excel, you would see it would populate your cells just like you would expect. Each row would be a line in your Excel file, and each comma would separate each of the fields working from left to right. Now, the CSV module offers us some more functions that we can use to process this data, and that is really and it's object oriented, so we have to take all that into consideration. So CSV is comma separated values, and we're basically taking our list now and creating tabular data that we can store on our hard drive or our SSD, okay? That is pretty simple to understand. So when we write to a CSV file to create that CSV file and do all the formatting for us, we actually have a function in the CSV module that we'll have to import that will do that for us. And it creates something called a writer object. And the opposite of that is a reader object, okay? So the writer object is used to write the data, and when we open the CSV file to read it into memory or to write, we have to take into consideration that new line at the end of each line we're going to have to eliminate it. Now, one thing that we will do, and this is interesting, we don't introduce this until we get into CSV, but now back to making our programs portable, you're going to see a named argument used in our functions here, maybe in our methods too, but in our functions, something called the universal new lines mode. And the thing that is important about that is the word universal, because that means that this code can be used in Windows or Linux or Unix, whatever. Okay. So first we need to take a look at the function and method. Okay, we have both that are coming with the CSV module that we're going to import. The writer function returns a CSV writer object for the file, and that writer object is going to convert the data into comma separated values. It's going to do the formatting for us. And then there is the write rows method of the CSV writer object, which is going to write all the specified rows to the file specified by the writer object using the CSV format specified by the writer object. That's a lot to get your head around. I realize that's not the easiest thing to understand, but when we get into that writer object, you can see that you will see that we can change the format from comma delimited actually to other delimiting characters if we want to. So there's actually several things we can do there. So let's look at a list of lists here. Now we're getting into it. We have 3 rows and there are 2 columns with each row. So that officially makes this a table, okay? A list of lists. You can see the enclosing square brackets here as we create this data, for example, okay? And we're going to import the CSV module to get these functions and methods that we need to make the magic happen here, okay? So now we're going to see that named argument when we open up files, CSV files, and process them. So with open, all that's the same, where this is going to be a write, so we're in write mode, but here's the named argument to get to that universal new line code, okay? So just new line equals a null, nothing in between it, and we're creating a file object, okay? So now we don't have to worry about that end of line character. We're just going with the universal, whatever it takes, okay, depending on the operating system. This is going to solve that carriage return thing between Windows and Linux, okay? So we don't have to worry about that extra character. That's why this is important. Okay, so we created this file object here. So we're going to create a writer object. And we're going to do that by opening up the CSV module and using the writer function here on file. That's creating this writer object. Now that we have this writer object, we can run write rows method to write the rows for the movies in our database, okay? So the contents of this file, as we said, this data up here would look like this if we were to open this file up and read it in a text editor. So to read data from a CSV file is kind of the opposite of what we just saw. We're going to create a reader object. We're going to use the reader function out of the CSV module and create a reader object. We're going to use a for statement with the reader object to read the data. And by default, the reader and the writer objects use commas to delimit the columns of a row and only add quotes to columns when necessary. That is the universal default behavior for CSV files, okay? At the end of the day, what you should see in a CSV file is each field separated with a comma and strings enclosed in quotation marks. That's really what they're trying for. If it is an integer or a float, it's still going to be a string, but it's not going to be enclosed in quotation marks. But true strings will have quotation marks. At least that's been my experience. Okay, so We can change this behavior, though. We can get away from the defaults, as we will see. So the reader function first, very simple, just reader and then the file that we want to read. And this will result in a CSV reader object for the file. The reader object is going to get the data from the CSV file. And because it's a reader object from the CSV method, it's going to know about the delimiters. Okay, that's really what we're talking about. And so now we're going to run all this through a for loop so we can read it. So to read data from a CSV file, we're going to open our open function. Notice the named object. Now that we're in CSV land, we're going to use that new line equals double quote there for that named object, and the other, or named argument, excuse me, and the name of the file is the first argument. Okay, creating this file object. Now that we've got that open, we can create a reader object by calling the CSV module .reader method, this reader method on file. So this reader object is actually file as a reader object. Now we can use the for loop, which once again is going to read one line at a time. We learned that earlier. So for row in reader, the reader object, now we can print. We can run each line through a print function here to see what's in there. And notice that we are doing this as it is a string, as if it is a string. It is a string, excuse me, not a string, a list. So the first index of the row, of each row, is going to be the name of the movie, right? And then we're going to concatenate to it a space and then a parens. And then we're going to change the second index to a string because we're inside a print method here, print function here. And then we are going to add to the end of that a right parens, and then the right parens to close the print function. So that should be fairly familiar to you from last week. Okay, if you did last week's labs, you should be in good shape. So here's the output to the console of our small little data file. Now, as far as changing the behavior of the reader objects or the writer objects of CSV's module, we can change the quoting method, okay? I don't know that you will ever do this, okay? But the default is csv.quote_minimal. We don't even see any options in this output. You'd have to do a little Googling here to figure out what the other options are. Just realize the definition I gave you in my notes and the definition here are the same. It just says it's going to use a delimiter between the fields. That delimiter by default is a comma. Okay, this is the default, but we could change it. And the quoting characters, double quotes. And we'll use the double quotes around true strings, strings that we want to stay strings, like the name of the movie. We don't even have to do anything. Those are all the default settings, but we could change them. To prove our point, we're going to change just one of these, which is delimiter, comma, we're going to change to a tab, okay? So if we were to do that when we create the writer object or the reader object, just a named argument, delimiter equals, and then this new character that we want for the delimiter. Because it's a tab, but then we have to have a \T to escape the T and all. So that would make it a tab. Now what's going to end up here, instead of our data in each line being kind of jammed up with commas between it, it'll be tab separated. So we'd actually have neat columns. I've also seen data files, flat file data files, where a vertical line was used for a delimiter, a pipe, if you know the characters on your keyword, a pipe, a vertical line. And that was used in the program. Actually, it's in that radiolinks.net website I was talking about a minute ago. It's a huge database, hundreds and hundreds, maybe 1,000 or plus lines in it. And those fields are pipe delimited because there are commas in some of the data, especially if the data is open to the public. The public does not know anything about delimiters and commas having superpower and all that stuff. So get to a character that they would not use, which would be a vertical line. Now you say, well, Bo, how do you know that your users will never use a vertical line or a pipe? They have, and they've screwed up my database. That's how you corrupt a database. I mean, I've actually had that happen. I have to go in and change their entries. And on top of that, I got to find them. That's the biggest problem. I have to go into the data and find it. All right, enough about my problems, right? So let's move into movie list 2.0. Now, the difference here is we are dealing with lists now, list of lists. We have 2 fields for each of the movies instead of 1 field. So that changes the game big time. Just realize once we go to the second field, it's a list of lists because each movie is a list, okay? And adding a 3rd or 4th or 5th field is just more the same. Please understand that because that is crucial to our future life doing this work. We're not going to be limited to such small data sets. Our data sets are going to be big, okay? So our output should be very similar to what we saw last week. So I'm going to move in here and you're going to see some little different coding in the write movies and the read movies because now we're going to do these as CSV files and as lists. So the first thing we have to do is we have to import the CSV module, the simplest things we forget. So we got to have that or the functions and methods don't work. This is the same. I like the note here. Finally, they're actually putting some notes in our examples, a comment here. Remember, these are love letters to yourself. Put those comments in your program so you can remember what you were trying to do. So we're creating the file name variable here for the name of our file that's in our current working directory. And so our first function that we're going to create is the write movies function. And movies is going to be our basically our list that we're going to create. And so we're going to use a with statement to open up the file in write mode. And we're going to use the universal new line character here. So you're just going to see that over and over again in CSV files. So new line equals, I don't know why this isn't the default. We've got all these other defaults, but it is not the default. So we have to enter it. We're creating the file object here. From that, we're going to create a writer object using the CSV module, the writer method on the file object to create the writer object here. Now we can get into the writer object methods that come with the CSV module. And so the writer module, the write rows method, and we're going to write movies. There's our list we're going to write. Read in the other direction. Reading from the hard drive into memory, we've got to create in memory a list. So movies is going to be our list. We open up the file name. Once again, new line argument is empty, and we're creating a file object. And here we're creating a reader object from the CSV module, reader method on file. And for each row in the reader object, we're going to append to this movies list that we've created in memory, a row, and then we're going to return the whole list here once we get through this function. So I think that is pretty much the only difference because we have a list, and we saw this code last week in our labs, maybe not exactly this, but something very similar, if not the same. We're going to list the movies by looping through the movies list that we now have in memory. We read off of the hard drive or SSD into memory, and you can see that code and all this good code here. All that should be the same thing. If I keep reading the same thing over, you're going to throw something at me. Add movies is dealing with lists, just like we did last week. We saw this code. and deleting movies, because all this is in RAM. It's the same as what we were doing last week. It's nothing to do with the hard drive at this point. So all this is in memory. And here's our menu system, and that's in memory. And then here's our main. So the first thing we got to do in main is display the memory. And then second thing is to read the hard drive and create that movies list so we can do some work on it. Now, the thing that I'm not seeing anyway, I don't see a writing a call to the writing. It's on page 1 here. This guy, write movies. And I'm not sure what the writers think. There it is right there. Okay, never mind. I just found it. There it is. We are writing the movies to the hard drive when we add movies. Okay, that makes sense. That helps me out a lot. And there it is when we delete movies, we're writing it. Okay, you probably already saw that and think I'm crazy, but I was just making sure we're using our functions that we created. Any questions? Moving along. I think we're right on time because we just have a little bit more to go. Now we want to introduce binary files. And you're going to think, well, this is anticlimactic. And it is. We just have to change our coding a little bit, and everything works in binary instead of CSV files. So we have to use the pickle module to get the tools that we need for binary saving of our data files. Okay. So primarily we want two methods to get this done. The dump method, which writes the object to a binary file, and the load method that reads the object from a binary file. So it's all object oriented still. Notice the syntax. We are going to deal with B files in our syntax. I like that because we know that this is a binary file. We're trying to separate kind of our understanding here. There's no super code there. That's just a reference to the file, but realize it's a binary file at this point. And so we're going to load to read and dump to write. Okay. So before you can use the pickle module to write a file, you have to import the pickle module, right? So make sure, just like with the CSV module, you import the pickle module if you're going to run binary. Our third lab this week is going to be a binary lab, so you're going to do this. And so then we can just write the list to a binary file. We use the same open function inside a while statement. You'll see that we're going to use a little different mode code. WB for write binary, it'll be RB for read binary, okay? And once you open the file in binary, then you'll see that the methods that we use are going to be a tad different than we saw earlier. So if we are going to talk the talk as well as walk the walk, pickling is the term that a lot of Python programmers will use when they're using the pickle module. That is not really academic, I guess, because serializing an object or serializing a data file would be a more preferred term for referring to using binary instead of text. Okay. And then the opposite of that, reading the file, would be deserializing. So starting off with the exact same data that we had in our CSV model or example, we're going to import pickle instead, okay? And here's the syntax that we're going to use. Our with statement into our open function, and notice WB for write binary, okay? Creating a file object. Then we have the pickle module, the dump method. Movies is the list that we're dealing with, correct? And file is the object that we have read, okay? So we'll see that in just a second in the example. To read the object, okay, To read the object, we're going to open the file that we have created. We'll open movies.bin here in RB. Notice we have to have a mode for binary read. It's not a default. So RB has to be there. And we're creating the file object, which is going to be a binary read. Okay. And so now we can create the object movie list from the pickle module and the load method, load the file in, and basically this takes the binary file and changes it into text so that RAM knows what to do with it. Okay, so it's reading that file into RAM, and then we can print it, and you can see it prints the way our other files did. It's printing the list of lists is what it amounts to here, because we do have a 3x2 database. Okay, so you can use methods of the pickle to work on binary files. I think this is kind of a review thing. Dump to write, load to read. Storing the data is called serialization, and reading the data off of the storage system is deserialization. Want to make sure you have those terms because they're on the terms list. They might be in a test somewhere. So let's look at movie list 3.0 because this one is going to be in binary. Okay. So you're going to see that we are going to use the pickle module for the write movies and the read movies functions we're going to create. And the list movies function is going to convert the movies year to an integer value from an integer to a string in order to display it. Because remember, binary will save integers and floats, whereas strings will not. Everything in a text file is a string. Text files are all about strings. Binary, we can have different data types. And that's one reason why people use binary over text. It is simpler for some programmers. So our interface is pretty much the same as what we've seen. So we'll just scoot past this. And all we're doing here is showing the differences in 3 functions. Other than that, the program works exactly the same as Movie List 2.0. So I hope you appreciate the fact that we're just changing how we are storing the data on the storage system. So we know right off the bat, we're dealing with binary here. We're importing pickle, and our data file is movies.bin, okay, for binary. But it's still called file name. We're creating the variable here. Create a, we're going to create a function here, write movies, which is going to be different because we have WB here, write and binary. And we're using the pickle function here, pickle module here, and the dump method from that pickle module to write the movies list, and file object is going to be written to it. Okay, so that's our destination, and that's the data that we're going to put there. Okay, and then read movies. Well, once again, just like we've been doing, we have to open up a list. Then we'll have our with statement, open up our file, RB, and we're going to read a binary file as file. And we're going to create the movies object, and we're going to load this into memory. Okay, so that gets us back to a movies list that we can process, and we return that movies list to the main function so that we can process it. The only other difference is down here in our print function when we do our list, because print requires strings, and since binary delivers that year as an integer rather than a string, then we have to use the string function here to change that year back to a string. So data types are always going to be around there to haunt us. So that brings us to the end of Unit 7. I hope that I've been able to shed a little bit of light on our challenges this week. We have some new terms in our term list, and they're all in here. Every new word that we had during the course of the last hour and a half. Here's the summary, and you can see the terms in context. So things to do this week. First thing's not on this list, and that is make sure you take test 2 today. If you have not already taken unit test 2 in this course in this class, today's your last day. So read chapter 7. You can download these slides if they would be helpful to you, please. I would download them. What's the point? Free of charge. You'd be surprised. Not many people download the slides, and I don't get that. I mean, I would keep them on my computer while I was taking the course at least. Complete the topic 7 in Blackboard this week. Keep up your good work. If you haven't been doing all your replies, it's going to start costing you points. And big points, more points. And you have 3 labs. So in lab 7.1, you're going to create a CSV file for a program called trip data. And then you're going to, in the second lab, you're going to read and write to that file. So basically, and actually the first lab is fairly long because you're creating all of the processing code for the trip data file, and then you're going to add to that in lab number 2. And then in lab number 3, 7.3, you're going to change trip data from CSV to binary. So trip data kind of starts off as a plain text file, then it's going to be a CSV file, then it's going to be a binary file. So good exercises this week. I looked over those yesterday. I thought we had some really good labs this week to help you understand this. Don't forget about Unit 7 quiz. Make 100 on that. Easy points. Are there any questions? How many people we got in class right now? 14. 14 people, no questions. Okay. Well, we're ending right on time. You guys have a great week, and we'll catch up with you next Wednesday afternoon and talk about how to deal with exceptions, how to handle exceptions will be our topic next week. Have a good week, everybody. Thank you.